Hello everybody, myself Dhiren Chetrapal. Today we are going to start one of the topic from the organic chemistry, and the topic name is nucleophilic substitution reaction. This nucleophilic substitution reaction topic is from organic reaction mechanism. Also, this topic can be observed in NCERT books from the chapter of haloalkanes as well as alcohol phenols and aldehyde ketones. Even amines also cover this, the nucleophilic substitution reaction. That means overall complete class 12th need this topic, that is nucleophilic substitution reaction. Before starting this lecture, I hope that you know the basics of the organic chemistry. So let's start nucleophilic substitution reaction. My dear, nucleophilic substitution reaction have two terms. The first one is nucleophilic. Actually, nucleophilic comes from the term nucleophile. And as we know from the previous knowledge that my dear, this phile is word come from love, and the nucleo is come from the nucleons. That means those species which are nucleus lover are known as nucleophile, or the species having tendency to donate the pair of electrons are considered as nucleophile. These are just some basics of the organic chemistry. Next term is the term substitution. Now, what do you mean by the term substitution? Substitution is just a general term in the chemistry. When we are saying that I want to substitute someone, this is known as substitution. Substitution, or you can say this is in a general term, this is known as replacement of someone from something from someone. Okay, this is just a replacement. Let's say if I am saying A and B are two friends, and just C want to replace B by the internal mechanism, so such type of basics is known as a substitution. Here C has a power to substitute B, or C has a power to replace B from its exact position. This term is known as a substitution. Now, as we discussed, now we are going to start nucleophilic substitution, or this reaction or this topic is also known as SN reaction or SN mechanism. My dear, first of all, SN mechanism actually further divide into two parts. The first part is direct method, and the second part is indirect method. There are two methods of substitution or nucleophilic substitution. Direct method cover three type of topics, that is SN1 substitution, SN2 substitution, and SNI substitution. Here I is actually known as internal, that is substitution nucleophilic internal. Okay. Indirect substitution also covered two parts. The first one is SNAR. Here AR is nothing, it is aromatic, that is known as substitution nucleophilic aromatic. And the last one is SN2 substitution. Okay, so they are the five type of substitution that we need to understand in entire topic of chemistry. Today we are going to start one of the topic that is known as substitution from direct substitution, that is SN1. Okay, so now let's start our topic, that is SN1. Again, SN1, there are three terms as we know, my dear. This S is again represents substitution as I taught, and N represents nucleophilic, while this 1 is represents the kinetic or order of the reaction. Order of the reaction. I believe that to know this topic you have the knowledge of chemical kinetics, that what is actually SN1 or SN2 and what is actually the meaning of order. Okay. Although during the time of this topic, I will try to recall some of the points that we need for this topic. Okay. So substitution, nucleophilic, first order. First order is what? Any reaction in which the rate of reaction depend on one of the reactants that is involved in the rate law equation or rate law is known as first order. Now let's suppose what I want to say, let's suppose we have an alkyl halide, that is Rx, and we have a nucleophile, and just we want to substitute followed by SN1 mechanism, by that is nucleophile will substitute this alkyl halide and take its position. Here my dear, this is alkyl halide, alkyl group, or you can say this is actually halogen group, or you can say leaving group, and this is our old nucleophile. Now we are going for its mechanism. What is mean by SN1? Why it says SN1? Okay. So what is the mechanism behind the SN1? Mechanism of SN1. SN1 mechanism reactions take place in two parts, or you can say two steps. The step number 1 is known as formation of carbocation step. Carbocation step. Formation of carbocation means, let's suppose we have the alkyl halide. In the presence of solvent, this alkyl halide will break in the form of R plus and this X minus. This X minus, and this R plus is carbocation over here. This is the actually step number first. I will go in the detail why this reaction is reversible, what the role of solvent, we will discuss later in this topic. But this is the first step in which the alkyl halide will break in the presence of solvent and convert to R plus and X minus. In the step number 2, that is known as attack of nucleophile. In this step, nucleophile will try to attack on the most stable carbocation, and this is actually the overall is known as substitution nucleophilic. Here we can say this alkyl halide is replaced by the nucleophile by the internal mechanism. Now we are going in the depth what actually the meaning of first order over. Then we will go for why or which type of solvent is used, and so many topics we need to cover in this topic. Now variable questions that are come in mind. First, question number first, as we know the step number 1, that is the formation of carbocation, is the slow step, and as per the definition of chemical kinetics, if the reaction is complex or the reaction take place in multi-step, then the slowest step in the reaction is considered to be a rate determining step. So I hope you know this step is actually the RDS, or the step which determine the rate of the reaction. That means we can say the rate of a reaction is directly proportional to the step number 1, or you can say directly proportional to the nature of alkyl halide. Something is nothing, its power should be 1, or you can say rate should be K Rx, and hence this is actually nothing, it is known as what? First order kinetics. I believe that you know the term order is. Order never be predicted by observing the reaction, order is always experimentally measured. From the experiment we consider this is to be 1, and we can say this is the first order kinetics. here we can say one of the most important point, that means if any change in the alkyl halide, it will directly affect the rate of the reaction. That means it can slow or it can fast the reaction if there will be slightly or any change in the nature of alkyl halide. How it will show, I will explain in this topic. But this actually meaning is, if there is a small change in the alkyl halide, will directly impact the rate. That's why this reaction is actually known as the first order kinetics, and the whole reaction mechanism is known as substitution nucleophilic first order. Now, what are the actual factors that are responsible for the first order kinetics? Factor that affect SN1 mechanism or SN1 reaction. First of all, we need to draw the graph by the help of chemical kinetics. As we know, if the reaction is more than one step or the reaction in two steps, so in the graph there should be two peaks. That is, as we know, that number of peaks is equal to the number of step in the chemical reaction. So here, my dear, we have two steps in the mechanism, so we need to draw two peaks. Okay, so this is the energy versus reaction progress. Now, my dear, as we know, the first step is actually the slow step and the second step is actually the fast step. As this step is slow, so it required high activation energy to achieve the transition state. This is the graph that we need to draw. This is the graph. Here some points are that we need to remember. This point is known as the starting point or known as alkyl halide. This is the first transition state where R and X bond are undergoing breaking. I believe that you know the term transition state. Transition state in the chemical kinetic is just an hypothetical state, and it is assumed that in this state the old bond breaking or new bonds are formed. And as we know, this state cannot be isolated because of their high energy. If you want to go this topic, you need to learn chemical kinetics. Okay, so transition state is the first transition state, and this point is known as the formation of carbocation or known as intermediate. After then, this is the second transition state where alkyl halide, where carbocation and nucleophile are undergo bond formation, and finally this is the product where R or nucleophile form their bond. Now, my dear, from this to this is known as the activation energy. I hope you know the term what is activation energy is. This is the activation energy first, and this is the activation energy second. I hope you know why this is the activation energy first is high and second is low. And just remember that the reaction which are slow in step require high activation energy, or the reaction which are fast in step required low activation energy. So this step required low activation energy and this required high activation energy. Overall in the terms of energy, you can rearrange in this form that the highest energy goes to the transition state first, and then it goes to the transition state second. Then next one is the intermediate, the third one is reactant, and the last, which should be the most stable, that should be the product. And these are some points that we need to learn in the graph. Some points which are very important to learn or to know, that is number of peaks in the graph is equal to number of steps. As we know, we have drawn the two-step reaction. So there are two peaks in the graph, point number 1. Point number 2, that is, as we know, the relation between the transition state is equal to intermediate plus 1. These knowledge are come from the chemical kinetics. Okay, this is the relation between the transition state and intermediate. If the intermediate is 1, then the transition state is 2. However, intermediate is not necessary for all the reactions. Okay, but in this reaction intermediate is created. That's why if intermediate is 1 and transition state is 2. So this is the basically the graph of SN1. Okay, I hope you will understand graph, why this graph is peak is high, this graph is peak is low. Okay, now the king of this whole is actually the carbocation. What I mean to say, what I am going to say, explain, that what are the factors that responsible for the SN1. The first factor that is need to learn or which affect the SN1 reaction is a nature of alkyl halide. As we know, the rate of reaction is directly proportional to the alkyl halide. Okay, so again this is Rx, that is any change in the nature of alkyl halide will directly impact the rate of reaction. How the nature will impact? How the nature is impact? Let's suppose we have 3 type of alkyl halides. Let's take an example also. This is, let's suppose, to be 3-degree alkyl halide. This is, let's suppose, to be 2-degree alkyl halide, and this is 1-degree alkyl halide. Now, what we want, that on breaking the alkyl halide, or let's suppose the 3-degree, by the help of solvent, this will form a stable carbocation. This will form a stable carbocation. Actually, whereas the 2-degree alkyl halide will this such type of carbocation of 2-degree carbocation, and for 1 we have this will be like CH3 CH2 plus. This is, I hope no, this is 1-degree carbocation, this is 2-degree carbocation, and this is 3-degree carbocation. My dear, as in the SN1 mechanism, more stable the carbocation, faster is the rate of reaction. Again, I am repeating this statement. More stable the carbocation, faster is the rate of reaction. That is, rate of reaction for SN1 is directly proportional to the stability of carbocation. My dear, any factor which increases the stability of carbocation will increase the rate of SN1 reaction. What the most important point is, any factor which increases the stability of carbocation will increases the rate toward SN1. This is the key and one of the most important point that need to learn for the SN1. So if the data is correct, now as we know, I hope you know this is the 3D carbocation contains 9 alpha hydrogens, and this is the 2-degree carbocation contains 6 alpha hydrogens. This is 1 degree carbocation contain 3 degree alpha hydrogens. As we know, and I hope you know, that more the number of alpha, more is the hyperconjugation, more stable is the carbocation, and hence more faster is the rate of reaction. And if so, then the rate of SN1 in the nature of alkyl halide should be 3 degree alkyl halide, then 2 degree alkyl halide, and the last one is 1 degree alkyl halide. Or again I am repeating, any factor which increases the stability of carbocation will increases the rate of reaction. Okay, so this is the first factor, that what I have already told. Any factor which changes the degree or the nature of the alkyl halide will changes the rate of reaction. So if we replace 3 degree to 2 degree or 2 degree to 1 degree, the rate of reaction will directly impact. That's why this reaction is actually the SN1. Okay. Now my dear, a question comes in mind that sir, 3 degree is more stable, right? Okay, fine. Then why it is more favorable toward the SN1, or why it will choose for the fastest rate of reaction? Question is, if 3 degree is more stable carbocation, then why it is chosen for the fastest rate of reaction? Actually, this terminology is actually explained from the chemical bonding. I believe that you know that, let's suppose we have the activation energy and this is the reaction progress. And as we know, 3 degree carbocation is more stable. So let's suppose its activation energy is this. This is the activation energy for 3 degree carbocation. Here is the activation energy for the 2 degree carbocation, and here is the activation energy for the 1 degree carbocation. Actually, as per the chemical bonding, this is actually MOT diagram. I hope you know the understand of MOT. Now nucleophile will come from the different plane and it will attack to the carbocation. As carbocation are sp2 hybridized or triangle planar shape and must have empty orbital. When we are saying sp2, that means there are 2 p orbital involved, while the rest p orbital is empty. And the nucleophile will in future will attack to that empty orbital. Okay, so actually the nucleophile will need to cover this gap and this gap. Okay, and you know it is very easy for nucleophile to achieve this gap or to achieve this barrier. That's why 3 degree carbocation has the fastest rate of reaction as comparison to 2 degree or 1 degree in the SN1. Okay, so final answer is 3 degree alkyl halide is more toward the SN1 than 2 degree and then 1 degree. Okay, now let's go for the question. Just we need which carbocation is more stable, or identify the SN1 reaction, or compare SN1 reaction rate. Question is compare SN1 reaction rate. Let's suppose we need to compare this SN1 reaction rate, or let's suppose we can take this. Okay, now question is compare the SN1 reaction. This led to be A and this led to be B, and we need to compare which is the fastest toward the SN1. Again, what we need to do, just break this alkyl halide and convert this into carbocation. This is the carbocation. When we will break this will this type of carbocation. Now, as we know, any factor which increases the rate of any factor which increases the stability of carbocation will favor the reaction. As we know, NO2 will behave as minus I effect over here, and this methyl will behave as plus I effect over here. So as we know, stability of carbocation is directly proportional to the plus I effect, plus H effect, or plus M effect, and inversely proportional to minus I, minus H, and minus M. This you need to learn, or I hope you know this data. This is the basics from the general organic chemistry. So my dear, if we compare this with this shows the minus I effect, this shows the plus I effect. Minus I effect will decreases the stability of carbocation by withdrawing toward itself, and plus I effect will donate or favor the stability of carbocation, and again more stable the carbocation, more favorable is the reaction, hence the A is more faster than B. So in such type of question, when we need to compare the SN1 rate, just think in mind, you need to identify which carbocation is more stable, nothing to do with this, okay? Fine. Now again compare for the next question. Let's suppose we have another question. This is like CH2Cl, or we have NO2, we have OCH3, we have CH3, and we have only CH2Cl. This question is same again. Compare. This is like supposed to be A, B, C, and D. Compare in toward SN1. Question is compared toward SN1, A, B, C, D. Now, again the same pattern will be used. Break the alkyl halide and form the carbocation. Break the alkyl halide and form the carbocation. Now go for the stability of carbocation. That more stable the carbocation, faster is the SN1. Again my dear, this NO2 group, I hope you know, this NO2 group will give minus R or minus I effect. This OCH3 gives plus R and minus I, and as we know, plus R is dominant over minus I in such question. In this case, plus I and plus H2 are the favorable, and the fourth one nothing is given here. So those factor which increases the rate for the SN1 will favor the rate of reaction. My dear, NO2 decreases the rate, OCH3 increases the rate, CH3 increases the rate. Now again there are two members which increases the rate. The first one is B and the second one is C. Now the question is which one will more increase. So I hope you know resonance effect is more dominated over hyperconjugation, and hyperconjugation is dominated over inductive effect. So if you know this knowledge, then answer will be B come first and then C. Now A and D. In the comparison between A and D, my dear, again A have minus I and minus R both, and both minus R and minus I effect decreases the stability of carbocation, hence decreases the rate of reaction. So final answer is D, and this one will be A. This is the final answer. I hope you understand what I mean to say. Okay. So this is the first factor, that is known as degree of alkyl halide for the SN1. Okay. Now next I am going for the factor number 2. I believe this is one of the most important factor which may differentiate between the SN1, SN2 and any factor others. This is known as effect of solvent. Before starting this topic, I know, or I believe that you know that So what are the terms solvents are? Solvents are the substance which make the reaction in proximity. Proximity means you can say it as attraction or love toward the substrate and reagent. Actually, solvent wants that substrate and reagent must be in proximity to each other, or there must be a strong force of attraction between them, so that they can form a new bond, and that the new bond should be more stable than the old one. This is actually the role of solvent over here. My dear, again, solvent are of two types. The one is the polar solvent and the second one is non-polar solvents. These all are the basics of organic actually, my dear. Okay. Again, polar solvent further divide into two parts. The first one is polar protic and the second one is polar aprotic. Okay. In SN1 mechanism or the SN1 reaction, polar protic solvent, shortcut is PPS, will favor the SN1 mechanism. Why I am saying this? Why I am saying this? That why polar protic solvents are used for the SN1 mechanism. Let's come back to the basic mechanism that what we have learned. Okay, this is the basic. My dear, solvent again have the role to make the reaction in proximity. Let's suppose I am using solvent as H2O. H2O has a nature of polar, that is having some electronegative difference between their atoms, and a protic, that means have tendency to lose the H plus ion. My dear, polar protic solvent has a characteristic. One of the most important characteristic of polar protic solvent is that polar protic solvent can dissolve the cationic part as well as the anionic part. Again, one of the most important point, I am repeating that polar protic solvent has a property to dissolve the cationic part as well as anionic part. It means when the alkyl halide tends to break in the form of cation or anion, suddenly this cation or anion again have the tendency to reverse back. And if do so, if it will take, then the carbocation will not get in the free form. Getting my point? Again, once we break the R plus and X minus, it forms the cation and anion. Imagine a situation in which a container, we have the cation and anion, and cation and anion will not wait. Okay, sir, if you are saying then we are still away from each other. No, it's not possible. Cation and anion tends to again remix to each other and then make the reaction in the backward direction. And that's why this reaction is actually slow in nature. Now, we don't want that the reaction to go in the backward direction. For do so, we need to add this polar protic solvent. By this, as we know, the beauty of the polar protic solvent can polarize the cationic part as well as it can polarize the anionic part. That's why in the SN1 mechanism, the role of the solvent is very, very, very important. And sometime in SN1 reaction, these polar protic solvent will in future will behave as nucleophile as well. Okay, some solvents have the beauty or the characteristic that it can behave as nucleophile as well. Currently we are using as a solvent that it can polarize the cationic part or anionic part, so that the reaction will not go in the backward direction. Okay, that's why polar protic solvent will favor the SN1 mechanism. Some polar protic solvents are, it can be water, it can be alcohol, carboxylic acid, HCl. There are so many polar protic solvents are there. Okay. So this is the second factor that affects the SN1 mechanism. Majorly there are the two factors. Some rest factors are also there, that is the nature of a leaving group. The third factor is nature of a leaving group. This is just a very simple factor. As we know, this is the alkyl halide, or this halide will behave as a leaving group over the mechanism as well, SN1. And as we know, let's suppose we have three different halides. Now, which one will consider as a good leaving group? So it's very simple. As we know, while moving from top to bottom in a fluorine to iodine, the bond length will increases, and if the bond length will increase, then the bond strength will decrease. Hence, it is easy to break this Ri bond as comparison to this Rf bond. And if it is do so, then Ri have the most power of or nature of the to behave as a good leaving group. So this is the last or the third factor, that is known as the nature of leaving group. Overall, the conclusion for the SN1 mechanism is any reactions in which the rate of reaction is depend on the nature of alkyl halide. Okay. However, effect of nucleophile is negligible because nucleophile will come in the next step. However, we will try to favor the nucleophile in such as a polar protic solvent, because they can behave as a solvent and in future they can also behave as a nucleophile. I hope you will understand this SN1 type of mechanism. Okay, I am not going for the stereo of this SN1 mechanism. In the next lecture or in the future lecture, I will try to record a recording for the stereo of SN1. I hope you will enjoy this lecture. Thank you and have a nice day. Thank you so much.